Dear students, this is a continuation on the series of lecture on the topic first shifting theorem. Now if you see here, we have to find L of t square e to the power negative 2t. We observed that we have to find the Laplace transform of product of two functions. One of the function is e to the power negative 2t. Then we know that we can apply the first shifting theorem. This question can also be rewritten as Laplace transform of e to the power negative 2t t square. I have rewritten this in order to show you how to apply the first shifting theorem. What does the first shifting theorem say? It says that Laplace transform of e to the power negative at f of t is equal to, we have to find L of f of t, and in the resulting solution we have to replace s by, now because we have negative a here, because we have minus a, we have to replace s by s plus a. If it was plus a over here, we have to replace it by s minus a. Now since we had minus a over here, it has to be replaced by s plus a. Now, while comparing these two, we observe that f of t in our given problem is t square. So, let us do this problem now. So, therefore, Laplace transform of the given question is e to the power minus negative 2t f of t, which is t square. Okay, so that will be equal to, we have to find the Laplace transform of f of t. What is f of t over here? It is t square. So we have to find the Laplace transform of t square, and we have to replace s by s plus, what is the value of a over here? It is 2. So s plus 2. So this is what we have to do. Now by using the Laplace transform result, where we know that L of t to the power n is equal to n factorial divided by s to the power n plus 1. So we are going to make use of this result now. So when we do so, we observe that here we have to find Laplace transform of t square. What is the value of n? It is 2. So it will be 2 factorial divided by s to the power n plus 1. N is 2. So 2 plus 1, which is 3. And in this we have to replace s by s plus 2. Now while replacing, we can remove the flower brackets and we can write, and what is 2 factorial? It is 2 into 1, which is 2, divided by s. Instead of s, we have to replace it by s plus 2. So now here we have s cube, so we will be having s plus 2 the whole cube as our solution. So therefore we have found Laplace transform of e to the power negative 2t t square to be equal to 2 by s plus 2 the whole cube. So now we shall move on to the next problem, that is problem number 12. Dear students, problem 12 is to find Laplace transform of e to the power at t to the power n. We observe that we have to find the Laplace transform of product of two functions, where one of the function is e to the power at. So we have to use the first shifting theorem, where we know that the Laplace transform of e to the power at f of t is equal to, we have to find the Laplace transform of f of t, where we have to replace s by, now what do we have here? Plus a. So it has to be replaced by s minus a. So we have to apply this theorem for this problem. So when we apply, we see that Laplace transform of e to the power at, instead of f of t, we are having t to the power n over here. So that is equal to, we have to find the Laplace transform of t to the power n, because f of t is t to the power n. And in the resulting answer, we have to shift s from s minus a. That is, we have to replace s by s minus a. And that is equal to, we know that the Laplace transform of t to the power n is equal to n factorial divided by s to the power n plus 1. We have already derived this result in our previous video lectures. So kindly follow that. So in this we have to replace s by s minus a. So on replacing, we get the solution to be equal to n factorial divided by, what is s going to be replaced? S minus a. So we will be having s minus a raised to the power n plus 1. So this is the solution of this problem 12. Next we shall do one more problem, that is problem 13. So this is problem 13, and I hope this will be the last problem under the topic first shifting theorem. So let us solve this problem now. Now if you see, we have to find the Laplace transform of t plus 2 the whole square multiplied with e to the power t. So this can be written as Laplace transform of, this can be expanded by using a plus b the whole square format. So when we expand, we get t square plus 2ab, because it's a square plus 2ab plus b square. So 2ab will be 4t plus b square, which is 2. So 2 square is 4. So this has to be multiplied with e to the power t. Now further, when we multiply with e to the power t, we get Laplace transform of, so t square when multiplied with e to the power t, we get e to the power t square plus 4t again multiplied with this. So 4 e to the power t multiplied with t plus, now 4 multiplied with e to the power t will give us 4 e to the power t. Now in this, we can use the linearity property and take the Laplace transform of each of the functions separately. So first will be Laplace transform of e to the power t square plus, using the scalar property, 4 can be taken out, and Laplace transform of the second function. So Laplace transform of e to the power t multiplied with t plus 4 is again a scalar which can be taken out, and Laplace transform of the last function, which is e to the power t. So now we have separated by using the linearity property and also the scalar property. Now we have to apply the first shifting theorem. So according to the first shifting theorem, when we have the product of two functions and when one of the function is exponential, then we can find the Laplace transform of the function f of t, that is the other function. So Laplace transform of t square, and in the resulting answer we have to replace s by, what is the coefficient of t here? 1, that is plus 1. So s has to be replaced by s minus 1. So similarly, plus 4, again this we have to find the Laplace transform of the other function, that is t. So Laplace transform of t, in which we have to replace s by, here also we have e to the power t, so s has to be replaced by s minus 1 plus, now if you see here we have Laplace transform of e power t. We already have the formula for Laplace transform of e to the power t. So we can, as of now I am writing L of e to the power t over here. In the next step, what is Laplace transform of t square? It is 2 factorial divided by s to the power 2 plus 1, which is 3. So by using the formula. So Laplace transform of t to the power n is n factorial divided by s to the power n plus 1. So here the value of n is 2. So it will be 2 factorial divided by s to the power 2 plus 1, which is 3. So in this we have to replace s by s minus 1. Then plus 4 multiplied with, this is t to the power 1. So 1 factorial divided by s to the power 1 plus 1, which is 2. So in this we have to replace s by s minus 1 plus 4 multiplied with, what is the Laplace transform of e to the power t? Laplace transform of e to the power at is equal to 1 by s minus a. Here the value of a is 1. So multiplied with 1 by s minus 1. So now we shall apply this, that is 2 factorial is 2 divided by, instead of s we have to replace it by s minus 1. So after replacing, you can remove the flower brackets. So it will be s minus 1 the whole cube plus 4 multiplied with 1 factorial is 1 only. So 4 divided by, s has to be replaced by s minus 1. So s minus 1 the whole square plus 4 multiplied with 1 is 4 divided by, we have this s minus 1. We can observe that we have s minus 1 cube here, square here, and s minus 1 over here. And so we can take the LCM. The LCM will be s minus 1 the whole cube. And when we multiply this, it will be 2 plus 4 multiplied with s minus 1 plus 4 multiplied with s minus 1 the whole square. You can either take the LCM and simplify this, or you can leave the answer with this step itself. So when we simplify this, it will be 2 plus 4s minus 4 plus, here s minus 1 the whole square will be s square minus 2s plus 1. So when 4 is multiplied with that, it will be 4s square minus 8s and then plus 4. So this plus 4 and negative 4 will get cancelled, and we have 4s divided by s minus 1 the whole cube. And on simplification, we get 4s square. So this term we have written. We have plus 4s and minus 8s. So it will be minus 4s. And then this has got cancelled, and we are left out with 1, 2. So plus 2 divided by s minus 1 the whole cube. So this is the solution of problem 13. So hope you have understood both the lectures. So with this, we complete the problems on first shifting theorem. In our next video, we will be learning the next theorem. That is, when we multiply a function by t, how it is changed. So that is what we are going to learn. We shall see that theorem and problems of depending on those theorems in our upcoming videos. Thank you.